Okay, so for this task, we're going to be performing our CBC differential. We'll be using our white blood cell counter app, which I can get up here, to help us tally our cells. And then we'll also be doing a white blood cell estimate, our platelet estimate, and then doing our white blood cell count, all of which we'll explain how to calculate later. But first, we get our slide, and we want to get this all set up. We're going to be looking at the monolayer. So we want to move this over. So start at 10, get everything adjusted, find our monolayer, there it is, and we're also, while we're at 10, 10, looking for any significantly large objects. Looks good. So now we will move over to our 40, our high dry, and then we want to adjust. There we go. Back to our top part here. So our staining quality is good. Distribution looks good. We want at least 50% of our red blood cells to be touching each other, and that's definitely happening in this sample. And then also want to do our white blood cell estimate. So what we do is we count the number of white blood cells that we see in each field for 3 fields, and then we get the average of that. So we can start doing that. Okay, so let's see. There we go. So, let's see. Okay, so for this one field, we've got 40. So then we'll move to our next field. There we go. Glasses make this more difficult. Okay, for this, count 32. And we go to our third field. Okay, for this one we have 50. So what we want to do is we want to average these three numbers. So we'll do that. We have our calculator here. So we want to do 40 plus 32 plus 50. We want to divide that by 3 to get our average. So we have 40.6. So we'll write that down, 40.6. We want to multiply that by 10 to the third power. So we'll do that on here. Multiply by 10 to the third power, which is also 1,000. And then we want to multiply that by 0.25. So what we get is 10,166 for our white blood cell count estimate. So we'll keep our tally of that. Put my pen back in my pocket. Okay, so now that we've done our white blood cell estimate and we've taken a look at our staining and our distribution, now we will move over to our oil immersion. So put a drop of oil onto our slide, and then we move to our 100 power, and we want to refocus our microscope. There we go. And then we want to get back into our monolayer area, which is the layer that we'll be counting. And again, we want to make sure that we're focused really well. There we go. Now we have a nice clear view. Okay, so once we've got everything all set up, we'll get my white blood cell tracker app up again. We're not going to use this to make our calculations, just it's helpful to, it lets you know when you've hit 100. We're also going to be identifying and keeping track of any abnormal red blood cells, any abnormal white blood cells. We're going to keep track of our platelets because we're going to want to do a platelet estimate. And then while we're keeping track of which type of white blood cells we see. So we'll take a look, and then we'll put them onto our counter. So actually I'm going to move the counter to this side so that I can hit it with one hand while I move the microscope. And we're going to count until we've counted 100 white blood cells. Okay, so here we go. And again, just like with all of our slides, we want to make sure that we are moving in a zigzag pattern so that we're making sure we're not going over the same field more than once. Oh, it makes a noise too. You don't need to have the noise. seeing some eosinophils, mostly neutrophils so far. So it's good to write down too the platelets that we're seeing per field. Been seeing about 10, but I want to make sure that we're writing it down because we're going to need that for our platelet estimate. For our platelet estimate, we're going to count the platelets in 10 fields. So for our first 2 fields, write that down. Band neutrophils. Not a ton of abnormalities, but we are seeing some. Okay, so we've counted our platelets for 10 fields, so we will average that and do those calculations after. We're almost at 100 white blood cells. Okay, so once we have 100 white blood cells, we are going to write down how many of each kind we have, and then we will do our math for that. So take a look at our counter. Okay, and then we'll also do our platelet estimate. So we can do our platelet estimate first with our calculator. So we have the average of, we wrote down, not in the most organized way, platelets per field for 10 fields. And average platelets per field should be between about 8 and about 20. So if looking at our numbers, it looks like we have kind of average numbers. So we will average these. 18, 11, 16. We want to divide it by 10. So our average platelet per field is 12. So we want to, I wonder if there's any way I can make it so we can see our calculations a little bit better. So we've got our platelet average is 12. So what we want to do from there is we want to multiply that by 15. So we'll do that. Times 10 to the third power. Do that again. And then we want to subtract 20,000. So for our platelet estimate, we got 16,000 by using our formula there. Okay, so now for our white blood cells. So to get our percentage of white blood cells, it is the number of each type of blood cell we found over 100. So our basophils would be 3 over 100, which is 3%. Monocytes, same thing, would be 3 over 100, 3%. Our lymphocytes, we had 14, so 14 over 100, got 14%. Our eosinophils, we have 4 over 100, so that's 4%. And we separated our neutrophils and our band neutrophils, but we'll put them together. So it gave us 76, so we do 76 over 100 equals 76%. And I like to double check it even though I know we had the counter to make sure that it all adds up to 100%. So we'll do that now. So 3 plus 3 plus 14 plus 76 plus 4 equals 100. So we have our white blood cell count for each type of our white blood cells. So now we were also, as we were looking for any kind of abnormalities, if we didn't see any, if we did see abnormalities, we would be keeping track of that, and they would be represented in the record as if they were greater than 10 per field. So didn't see more than 10 per field, so we wouldn't have to estimate that. But in cases where you are seeing a lot of abnormalities, you want to make sure that you record all of those. So we'll record this in our record, and we will go over each type of white blood cell and discuss the causes of what some increased numbers might be. Okay, so now that we've completed our CBC, we're going to take a look at the different kinds of white blood cells. So we can start with first our neutrophils. These are the types of cells that you will be seeing the most of in your CBC, hopefully, if you have a relatively healthy patient. Our mature neutrophils are kind of segmented like this. We could also have our young neutrophils, which we call band neutrophils, that kind of have a kind of a C shape or like a rainbow shape. And neutrophils can present with infection or some inflammation in the system if you're seeing a lot of them. Next we have eosinophils. These are kind of similar looking to our band neutrophils, except the edges are a bit rounder and that middle bridge is much thinner. So that's a good way to be able to tell them apart. And when we're seeing elevated levels of eosinophils, it's usually because of like an allergic reaction, something that is going to stimulate the immune system. Sometimes you will see it with a parasitic infection. So those would be some of the things that would cause our eosinophil levels to increase. Next we have our basophils. These are kind of dark stained little circular cells with kind of a jagged dark nucleus. These are pretty rare to see, but when we do see them, again, it could be an allergic reaction, something triggering an immune response. It could also be a sign of infection if you're seeing an elevated number of these. Next, we have our monocytes. These are our kind of big cells with our irregular edges in the middle there. Almost looks like our band neutrophil or our eosinophil in that middle C area, but kind of larger, more jagged. An increase of monocytes is usually caused by an infection somewhere in the system. So that's when we end up seeing more of those. And then finally, we have our lymphocytes. These are pretty easy to spot compared to the other ones because they look a bit different, and they've got that large kind of dark staining nucleus that makes them kind of easier to differentiate from the other types of white blood cells. And when we're seeing a lot of lymphocytes, it can be due to things like infection or some inflammation in the body somewhere. So that is our different types of white blood cells. And now we will take a closer look at how we are calculating these. Okay, so now we will take a look, a closer and more organized look at our white blood cell calculations. I know we kind of scribbled them down during our CBC at the microscope, but it's always good to go back and check your math and kind of show your formula and make sure that everything is as it should be. So we'll start with our white blood cell estimate. And the way we calculated that was we took an average of 3 fields, and then we multiplied that by 10 to the 3rd power. So our 3 fields were 40 plus 32 plus 50. We took the average of those, so we added them up, divided them by 3, and then multiplied it by 10 to the 3rd power. And then we multiply that by 0.25. So we got 10,166. So our average ranges are 6,000 to 17,000 per microliter. So for our white blood cells, we were kind of in our normal range there. Okay, so now we will move on to our platelet estimates. So for our platelets, well, there are actually a couple of different formulas depending on the unit of measurement that you are using. But so our textbook formula is taking an average of 10 fields and multiplying that by 20, and then taking that number and multiplying it by 10 to the third power. So if you'll see here, in some other reference materials, it says 15. So you could do 15 or 20. I think while we were calculating it kind of on the go during our count, we used 15. And then there are also some other references that, so you use the above formula and then you subtract 20,000. But for the purposes of this and our textbook, we will use our original formula. So we took the averages of our 10 fields. So we got an 8, a 10, 15, a 10, a 10, an 11, a 15, 16, 7, and 18. So we added all of those up, divided them by 10, got the average of 12. And then we multiplied it first by 15, and then multiplied that by 10 to the third power. And this is another reason why it's good to go and rewrite everything down and double check your math, because we missed a 0 while we were kind of scribbling things down and punching it into our calculator. So we had said 16,000, it would have been 160,000, and that was subtracting the 20,000, but really, if we're doing the math right and going by our correct formula, it would be 180,000, which is just a little bit low. Usually like a low normal for our platelets would be 200,000 per microliter. So then if we redo it by our 20, going by 20 in the formula, so 12 times 20 times 10 to the third power, we got 240,000, which is more in the normal range. And the reasons that sometimes platelets could seem a little bit low, even if they're not, is if they are clumping. And so you think you're just seeing one, but there are multiples there. Things like that could affect your platelet estimate. So it's always good to double check. So finally, we have our white blood cell count. So we counted 100 white blood cells, and we used our counter app to categorize them to make sure we were counting how many basophils, how many eosinophils, etc. And what we then do, our formula, is to take the number of that type of white blood cell and divide it by 100. And that is the percentage that you would get for your white blood cell count. So we had 3 basophils that we saw out of 100, so that gave us 3%. 4 eosinophils, which gave us 4%. We had 76 neutrophils, which gave us 76%. We saw 3 monocytes, which gave us 3%, and then we saw 14 lymphocytes, which gave us 14%. So those are our calculations for our white blood cells in our complete blood count and differential.